Hi everyone, we are from Group 3. We are going to discuss the application of thermodynamics. So now we have a look about what is thermodynamics. The definition of thermodynamics is the branch of physics that deals with the relationships between heat and other forms of energy. It describes how thermal energy is converted to and from other forms of energy and how it affects matter. There are 4 laws of thermodynamics: the zeroth law, the first law, the second law, and the third law. The zeroth law. The zeroth law states that if two bodies are in thermal equilibrium with some third body, then they are also in equilibrium with each other. This establishes temperature as a fundamental and measurable property of matter. The first law. The first law states that the total increase in the energy of a system is equal to the increase in thermal energy plus the work done on the system. This states that the heat is a form of energy and is therefore subject to the principle of conservation. The second law. The second law states that heat energy cannot be transferred from a body at a lower temperature to a body at a higher temperature without the addition of energy. And lastly, the third law. The third law states that the entropy of a pure crystal at absolute zero is zero.
One of the thermodynamics theories is Otto cycle. Otto cycle is an ideal thermodynamic cycle which makes your gasoline-fueled car to move and speed up by performing a 4-piston strokes of the car's engine. The purpose of Otto cycle is to describe how heat engines turn gasoline into motion. This cycle turns chemical energy into thermal energy and then into motion. Secondly, it describes how internal combustion engines work, like automobiles and lawnmowers. This is the picture of the Otto engine. Cylinder is the space to which piston travels up and down. Top dead center is the farthest point of the piston's upward travel. Bottom dead center is the farthest point of the piston's downward travel. Stroke is the point when the piston travels from bottom dead center to top dead center or vice versa. Intake valve is the one that introduces the air and gasoline mixture into the cylinder, while exhaust valve is the one that evacuates the unburned gases from the cylinder. The next one is spark plug. It provides heat energy by its spark. And the last one is piston that converts the heat energy from the combustion into mechanical energy that will rotate the car's wheel. And now I will pass to Faqhrullah for further explanation.
Today I would like to do explanation regarding the Otto cycle. So the Otto cycle is a 4-step cycle where the internal combustion engine convert chemical energy of a fuel into a mechanical work. The cycle is as follows. So for the first, the fuel and the air are drawn into a cylinder. This part we call is a cylinder by the piston downward movement. So due to that, we could see based on the graph P pressure against the volume cylinder, we could see that the volume R increases because we could see that fuel and air fulfill this cylinder space, which cause the volume in the cylinder R increases. So the next step is the fuel and air mixture is compressed by the piston moving upward. We could see that if we move upward the piston, so the pressure in the cylinder decreases. We could see based on the graph. So based on the graph, we could see that the pressure on the graph increases due to the compression of this piston. So the graph we call as a compression stroke. So for the next stroke, the energy in this combustion have been utilized by the engines, which can cause the pressure in this cylinder are being decreases. So we could see in this graph the pressure have been decreases due to energy utilized by the engine. So this stroke we call as a power stroke, because the energy that we absorb by the engines are used to move the tire that make a car moving. So next, after the fuel and water has been used, of course it will produce waste. It should be evacuated by heat rejected. That's why when the waste are rejected, also the pressure decreases. So finally, the hot exhaust gases are forced out of the cylinder by the piston moving upward. We could see in this figure, the pistons are going upward and push out the waste out of the engine. Based on the graph, we could see the engine will force out the waste that cause the volume in this cylinder are being increases. So that's why this graph are moving left. And that's all for me. Next, I will pass you all to the next presenter. Thank you.
Okay, just now my teammate already discussed about the application and also the theory of Otto cycle. Now let's move on to the mathematical terms of function in Otto cycle. So this is the term that we use frequently in the Otto cycle, which is thermal efficiency. So here is the formula of the thermal efficiency. E is equal to the work cycle divided by the input energy. So from this formula, we can derive it into 1 minus 1 over R power of gamma minus 1. So today we didn't discuss too much about how it derived into this formula. However, we more focus on the relationship between this formula and the function. So for the E, it stands for thermal efficiency, while for the R, it stands for compression ratio, and the gamma is stand for the heat capacity ratio. Normally the heat capacity ratio in the air will be 1.4. So let's move on. So for the function, they will always have an input and they will always have an output. So we can see the formula of the efficiency. The input will be the compression ratio, while the output will be the efficiency. So I will show you the relationship between the efficiency and also the compression ratio. So when the compression ratio increase, the efficiency will also increase. So here is the graph for the relationship between E and R. So I think that is all about the mathematical terms of function in Otto cycle. I'll pass to my teammate to explain more about the example and also the solution by applying this formula. Thank you.
Questions for this topic is: an Otto cycle has a maximum efficiency of 71% and a compression ratio of 8.9. What is the gamma ratio of the working substance? Now I will pass to Rishi to talk about the solution for this question.
Hello everyone, my name is Rishi and I'm going to show the solution for this question. First, let's start from the equation. Okay, this is the equation for efficiency, which is E equal to 1 minus 1 over R power of gamma minus 1. Okay, since we need to find the gamma, there is a negative. So we need to move negative 1 over R power of gamma negative 1 to the left side, so then the negative is gone. Then we need to flip over so that we can get R power of gamma negative 1 equal to 1 over 1 minus E. Okay, since we need to solve for gamma, we need to add ln to the both sides so that we can bring the exponential to the in front. Then we can arrange the equation so that we can get gamma equal to ln 1 over 1 minus E over ln R plus 1. Okay, since we have the value for efficiency and compression ratio, we can substitute. Okay, E equal to 71%, which is 0.71, and compression ratio, which is R equal to 8.9. Then we can calculate and can get answer for the gamma. Okay, that's all from me. Thank you.
Hello, ladies and gentlemen. I'm going to conclude this presentation with the credits. First of all, we have Mei Wen, who worked on the introduction, thermodynamics definition, and conclusion. Then there is me, Rashmin Rahman. I also worked on the thermodynamics definition and conclusion. After that, we have Aisyah, Atikah, and Mohammed Faqhrullah, who explained the theory and application of Otto cycle. Next up, we have Wong Zhong Han, who stated the efficiency equation of Otto cycle. Subsequently, we have Ardiana and Rishi Varma, who did the question and solution based on the application. Lastly, we have Nur Ain, who compiled the videos. I hope everyone enjoyed and acknowledged the video. Thank you for the patience and good day.